Hi everyone. So this is Unit 6, Lesson 2, Right Angle Trigonometry. So before we begin, very important. This is something that you need to do before you do any work, and definitely need to do it before you write any tests or before you write your exam. If you don't do this, you could end up losing a lot of marks. So we're going to be working with sine, cosine, and tan. So sine is S-I-N-E, but usually on a calculator it's written as S-I-N. Cosine is same, C-O-S-I-N-E, but on a calculator it's usually cos, like this. And tangent, which is usually just tan on your calculator. So to answer some of these questions, you need to use these buttons on your calculator. But you want to be careful because the calculator needs to be on the right setting, or using these buttons will not give you the right answer. So the reason for this is because these functions, so to speak, are basically used to convert angles to ratios. And the problem is that angles, there's more than one way to measure an angle. So you can kind of think of this as like if you're measuring distance, right? You can measure distance in kilometers, you can measure distance in miles, you can measure distance in leagues if you're like a 19th century mariner or something. But you have different units of distance, and if you don't convert properly, you're going to get the wrong answer when you put miles in when you're supposed to put kilometers or something like that. So for angles, it turns out that there are usually three major units for angles on a calculator: degrees, which we all know, radians, which is going to be important in the future, and g-radians, which unless you're doing surveying or something in Europe, probably don't matter. So it's really important that your calculator is in degree mode. Okay, if it's not in degree mode, your sine, cosine, and tan answers will be wrong. So make sure you put your calculator in degree mode. So how do you know if your calculator is in degree mode? I'm going to show you two different ways you can know. Every calculator is different, so it's a little bit hard for me to generalize here, but generally speaking, if you have a calculator, you'll see DEG on the top somewhere if it's in degrees. You'll see RAD if it's in radians, or GRAD if it's in G-radians. So you want this to be in degrees. Okay? What if you don't have that, or you're still not sure? Well, a basic test you can do is try calculating sine of 30. So put 30 in, hit sine. Does this calculator have a sine? I really hope it does. I'm assuming it does because it has degrees here, but I'm not sure where sine. Oh, there it is. No, that's sine. There it is, above the 7. Okay, so if you hit sine of 30, if you're in degree mode, you should have an answer of 0.5. Okay, so if you don't get 0.5 for sine of 30, you're not in degree mode and you need to change it. Okay, so how can you change it? Unfortunately, this is hard to kind of generalize because different calculators do it differently. What I've seen, some calculators, if you hit the mode button, will have an option of maybe 1, 2, or 3 for degrees, radians, g-radians. You might have to go further down a menu. Maybe it's 4, 5, and 6 or something like that, but it might be in mode. Maybe potentially could be in setup. Or my calculator, which is old, has a DRG button somewhere in here, which goes between degrees, radians, and g-radians. So you have to hit that button multiple times and it kind of cycles through. So find out how to do that on your calculator. If you're confused, maybe try and meet with me on office hours. We can try and figure it out, but make sure your calculator can go into degrees. Also, you can do this on a phone calculator. Now, I don't recommend that you use a phone. Please don't. But if you turn your phone sideways, you'll often get assigned to the calculator, as hopefully you're aware. On a phone calculator, at least mine, it's a little different. There's an actual DEG button, and if you press it, it turns into RAD, and if you press it again, it turns into DEG. So you might find an RAD or DEG button that you can press. Okay. Also, if you're using Desmos, be aware that Desmos can use both modes as well. Okay, so once your calculator is properly set up in degree mode, you can proceed with the rest of the lesson. So I'm going to assume that you've done that, and here we go. Learning goals. I'm going to be asking you to find missing sides of right angle triangles using SOHCAHTOA, or find missing angles if using SOHCAHTOA. So you can use SOHCAHTOA to find angles or sides, and there's going to be word problems involved with this as well. So we're only working with right angles today. That's why this lesson is called Right Angle Trigonometry. So every triangle that we deal with today is going to have a 90-degree angle somewhere. And we're going to use this thing called SOHCAHTOA, which hopefully you're familiar with. But if you're not, let's quickly review that. So if you pick an angle on a triangle that has a right angle, so we're going to ignore the right angle because we know that's 90 degrees. Let's just pick another angle. You can relate the other sides of the triangle to that angle. So every right angle triangle is going to have a hypotenuse, which is easy to figure out because that's just the longest side, and it's the side that's opposite the right angle. But every triangle is also going to have opposite and adjacent sides. And this can be a little bit confusing because opposite and adjacent kind of change. Like this side says opposite, but this side could also be adjacent. That depends on what angle you're looking at. So the word adjacent means next to. The word opposite, well, that means opposite, right? On the opposite side. So if this is the angle that we care about, this side is opposite and the side below is adjacent. Okay? Hypotenuse doesn't change, it's just the longest side. But if you're talking about this angle, this side is opposite and this side is adjacent. But if you're talking about this angle here, this side would be adjacent and this side would be opposite. So it depends on where your angle goes. And the way you can tell pretty easily, there's a couple different ways, but whatever side that your angle touches that is not the hypotenuse, whatever side it touches is the adjacent side, right? Adjacent next to. So it's going to touch that side. So this side would be adjacent for the shaded angle. Okay, so now that we know, hopefully, how to label a triangle as hypotenuse, opposite, and adjacent, depending on the angle that you're looking at, we can understand sine, cosine, and tan. So sine goes with the ratio of the opposite side over the hypotenuse. So if you were looking at this angle and you wanted to relate it to the opposite side and the hypotenuse, you would use the sine button on your calculator. If you're looking at this angle and instead of relating the opposite side to the hypotenuse, you want to relate the adjacent side to the hypotenuse, then you're going to use cosine. If you have this angle and you want to relate the opposite side to the adjacent side, then you're going to use tangent. So SOHCAHTOA, right? S goes with O over H, or opposite over hypotenuse. C for cosine goes with adjacent over hypotenuse. T for tangent goes with opposite over adjacent. And I kind of worded that kind of vaguely because I said if you have this angle and you want to do something with the opposite side and the hypotenuse, that's kind of vague. But the reason it's vague is because it depends on what you're trying to do. So we'll see examples of that in just a second. Okay, keep in mind that SOHCAHTOA only works for right angle triangles, so don't even try this if you have, unless you know for sure that that's 90 degrees. If it's not 90 degrees and you try this, you will get the wrong answer. Okay, example 1. Find the length of the side x, which is here, to the nearest tenth. So what we need to do then is find this side. So I'm going to take you through a few steps. So I've listed them as 4 steps that you can kind of do step by step to get answers to these right angle triangle problems. Okay, so step 1. What you want to do in step 1 is label each side of the triangle based on the angle that you are concerned with. So we're given 37 degrees here, so this is the angle that we're concerned with. The longest side is the hypotenuse, so that's going to be this side here. If this is the angle we're concerned with, then it's touching side CB, which will be adjacent, and opposite that is side X. So I'm going to label my triangle. This is the hypotenuse, this is the adjacent side, and this is the opposite. Step 1 is done. Everything is labeled. Step 2, let's write down the information that we have and the information that we need. So we have angle B here is 37 degrees. I have that written as theta. I'm going to change that to B. So B is 37 degrees. Okay, I have the hypotenuse of the triangle, which is 10.3 degrees, and I'm looking for the opposite side. Okay, so this is where that sort of vague thing that I was talking about comes into play, because I have the angle, right? And I want to do something with the opposite side and hypotenuse. So I want to use the opposite and the hypotenuse, right? So remember, what does opposite and hypotenuse go with? So opposite and hypotenuse goes with S, right? SOHCAHTOA. So we're going to be using our sine ratio. Okay, so since we have the hypotenuse and we need the opposite side, those are the sides that we're concerned with, and that goes with sine. So now we can set up our problem. So sine of B is equal to opposite over hypotenuse. And now we just plug in our numbers. So 37 degrees is our angle B. Opposite, we don't know what it is. That's x. And your hypotenuse is 10.3 units long. Okay, so now we're just doing some algebra here. So I want to get rid of this 10.3 on the right side. So I multiply both sides by the equation by 10.3. It cancels on this side, and I get 10.3 times sine of 37 is equal to x. And you will then do this on your calculator. So 10 times sine of 37, again, making sure your calculator is in degree mode, should give you an answer of 6.2 units, approximately. You will need to round it. Most of the time when you take a sine or a cosine or a tan, you get an irrational number that's not very nice. So probably you're going to have to round it. Okay, next question, example 2. Find the length of side x to the nearest tenth. So here we have side x. Step 1, let's label our triangle. This is the longest side, so that's your hypotenuse, right? Your hypotenuse can be on the bottom if this triangle is tilted a certain way, so be careful about that. We're concerned with this 51 here, and so that is going to be the opposite side to that 51, and that's going to be the adjacent side. So we label those. Step 2, write down the information we need. Okay, so we have the opposite side, which is a measure of 8 units. We have the angle, so again, instead of theta here, I'm going to call that A. Angle A is 51, and we're looking for side x, and side x would be the adjacent side, x. So we have an opposite, we're looking for an adjacent, so SOHCAHTOA, OA, OA, so that goes with T, that goes with tan. So that's going to mean that we're going to have to use a tangent ratio to solve this problem. Okay, so actually, you know what? I'm going to go back to theta. The reason I'm going to do that is because I've used big A for adjacent. So let's just pretend that this is angle theta. Okay, so tangent of theta is equal to opposite over adjacent. So tangent of 51, we plug in our numbers. The opposite side is 8. The adjacent side is x. I want to get this x out of the denominator, so I multiply both sides by x, and it cancels there. And that gives me 8 is equal to the tangent of 51 times x. Okay, I want x by itself, so I'm going to divide both sides by tan 51. So x is equal to 8 divided by tan of 51. Keep in mind when you're doing this, you do the tan 51 first, and then do 8 divided by that number, and you'll get about 6.5 units. Again, this is a rounded number, which is why we use the approximate sign here. Okay, moving on. Now that we've practiced a couple different ratios, we've seen a sine ratio and we've seen a tan ratio, we've been trying to figure out how long sides are. But we can also use these ratios to figure out the measure of an angle as well. We can kind of work backwards. And so we're going to go do a couple of examples that show that. So say I have angle theta here, and I have this side and then this side. I want to find what theta is in this question. So again, labeling our triangle, same as always, longest side, that's your hypotenuse. Theta is what we're concerned with, so this is the side that's adjacent to it, that's touching it. So that's 12, that's adjacent. This side will be opposite. Write down the information that we need. So we're trying to find angle theta, we don't know what that is. We have the adjacent side to theta, and we have the hypotenuse, so that's 12 and 13. Okay, so that's an AH, so SOHCAHTOA. Right, AH goes with C, so we're going to be using cosine here. We set up our equation to solve, so cosine of theta is equal to A over H. We plug in A over H, so 12 over 13. At this point, you could work this out, or you could just kind of leave it as 12 over 13 if you want it to be more accurate. But we're kind of stuck here now, because how do you get rid of this cos? And so you can't really, cosine is not a number, so you can't divide out a cos or something like that. We need another way to get rid of it. Okay, and so what we do is we use the inverse of cosine, sometimes called arc cos. I've seen arc cos written on a few calculators, or you might see it written like this, to the -1. So that means the same thing. So if you do this to both sides of the equation, it gets rid of cos. You can think of this as like the undo cosine button, if you like. Inverses are like the undo function of mathematics. So you have arc cos, which is cos to the -1. You also have arc sine, which is sine to the -1, and arc tan, which is tan to the -1. So all of those functions should be on your calculator. If we look at this one here, we can see we have sine on there, and we have arc sine there, sine to the -1. Okay, so that -1 doesn't mean raised to the exponent -1. It's telling you that it's arc sine. It's telling you that it's an inverse. So now I'm at this point, and I want to get rid of this cos. So I do cos inverse on both sides, arc cos on both sides. That's going to turn this into just theta, which means I have to calculate arc cos 12 over 13, and that's what this looks like now, right? So if I use arc cos on both sides, the cos goes away on the left, and you get it here. If you want, you can kind of think of it as moving cosine over. You can think of it that way too. So if you want to move cosine across an equal sign, then it becomes cosine -1. Okay, so you do that on your calculator, and you get 22.6 degrees. Again, this is rounded. So please don't cancel anything, right? Sine, cosine, tan, they're not numbers. You can't do that. You have to use the inverse. All right, great. Last question, example 4. So now we're going to look at a word problem. So you have Captain Jack navigating his ship to Port Harbor, which is north of the ship's location. So if the ship is here, J for Jack, and the port is P directly north. And assuming the point on the shore is 20 kilometers from his position now, because this is the point he's aiming for, the distance to that point is 20 kilometers. And we're also told that it's 5 kilometers. The point that he's aiming for is 5 kilometers from the port. Okay, so we got that triangle. So assuming that the point on the shore is 20 kilometers from his position now, at what bearing must Jack head his ship? So this is maybe a little confusing. Let's explain this a little bit. You probably have some familiar with this. If you've ever gone canoeing and you've been in a wind, you maybe have dealt with this situation. Or you can see this sometimes if you're maybe throwing a ball. You may be aiming at a person, but the person is running, so you don't throw it at the person, you throw it beside them, and they will run and catch the ball. So that's kind of what's going on here. So the water is moving, and so if you try to go straight to the port, the water's going to push you to the side, and you're not going to get there. So I'm guessing that the water is actually pushing this way to the right, and so if you go straight at the port, you're not going to get there. You're going to be pushed downstream somewhere here. So what you want to do is aim this way, and then when the water pushes you, you end up over here. So he's trying to aim 5 kilometers to a point 5 kilometers west of the port, so that when the water pushes him, you'll end up at the port. Okay, so you've got this triangle. So we want to head to this point. This is where he's aiming to head. So we want to know what angle we have there that will get him to that position. So that's our triangle, right? We have 20 kilometers to that point. 5 kilometers between that point and the port, and we're looking for this angle. Okay, so simple trigonometry ratio again. So this would be the hypotenuse. This is the longest side. This is opposite of that angle, so this is opposite, and this is adjacent. So we have the hypotenuse and the opposite side. So that's a sine ratio that we're going to be dealing with. So sine of this angle is equal to the opposite over the hypotenuse, which is 5 over 20. So that gives you 0.25. Okay, but remember that's still sine of theta on the left-hand side, and we need to get rid of that sine. Or if you like, we need to bring the sine to the other side. So we change that to an arc sine. Arc sine of 0.25 gives you 14.47. And so Jack must head on a bearing of approximately north 15 degrees west. I'm not going to really bother you with bearings on the exam or the test. So if you're not quite sure what that means, just as long as you know that angle is 15 degrees. But what that means is you can think of north and west. So it's telling you north, then 15 degrees in the westerly direction. So that's what this means. So it means if you look due north and then go 15 degrees, you're here, 15 degrees in the west position. Because you could go north 15 degrees towards the east as well, right? So you're in there. Okay, draw a diagram that shows the relative position of Captain Jack's ship and the submarine. So we have part B here. Captain Jack is in communication with a submarine that is cruising at a depth of 400 meters below sea level. If Jack's radar tells him that the submarine is 500 meters from Jack due north of his ship, what angle is the submarine located with respect to Captain Jack's ship? Okay, so this question, you actually don't have a picture, so you actually need to think about what this looks like. Okay, so the submarine is 400 meters below sea level. Jack's ship is going to be on the sea, so they're going to be 400 meters apart as far as depth. But the submarine is 500 meters from Jack due north of his ship. So what does that look like? It'll look like that. So the ship is, a submarine rather, is 500 meters away from him, and it's 400 meters lower than him. Okay, so we want to figure out what's this distance here between him and the submarine, just looking at as far as on a compass goes, right? So this is the picture that we're looking at. Okay, and we want to know what angle is there between him and the ship. So let's just see that in the question. Yeah, so what angle is the submarine located with respect to Jack's ship to the nearest degree? So we're looking for this angle here. This is not the angle of depression, by the way. If you're looking at angles of depression, that would be here. But we're just looking for this angle between going straight down and the ship. Okay, so simple trig problem now. If this is theta, this is your longest side, that's your hypotenuse. This is opposite, this is adjacent. So you're looking at a hypotenuse and an adjacent, so this is a cosine. So cosine theta equals 400 over 500. You want to get rid of this cos, so you use arc cos. And when you do that, you get that the angle there is 36.87 degrees. So the submarine is approximately 37 degrees north of Jack's ship with respect to the line that points down from the bottom of the sea. That's a bit confusing as well because this direction, well, I mean, it shows you this direction's north. Again, don't worry about bearings and compasses and anything like that on a test. I'm just going to be asking you for this angle. So if you can understand how they got 37 degrees there, then you're okay. Okay, I've put this here if you're actually wondering what sine is, just if you're extra interested in something. I don't know. As a student, this kind of bothered me until I got into calculus and I kind of understood it a little better. What actually is sine? So if you're interested, you can read through this. This is not on the test or the exam. You won't find it in your textbook, so don't worry about it. But if you're interested, it is kind of interesting. Okay, so you have questions to do. So these are the same questions that I've posted on the Brightspace website. And just to wrap up, learning goals here. Can you find missing sides of a right angle triangle using SOHCAHTOA? Can you find missing angles of a right angle triangle using SOHCAHTOA? And can you solve word problems by drawing a picture or analyzing a picture and then using the same two techniques here? That's it. Thank you.